n is an integer, prove algebraically that the sum of half n brackets n plus 1 and half brackets n plus 1 multiplied by n plus 2 is always a square number. So the sum of two numbers is when we add together the numbers. So we want to prove that half n brackets n plus 1 plus a half n plus 1 brackets n plus 2 is always a square number. So in order to do this, we'll want to expand out these brackets. So if we start off with this first number here, a half n multiplied by n gives us a half n squared, and then half n multiplied by 1 gives us half n. And now if we move on to this second number here, we can first start off by expanding out these brackets here. So it can sometimes be helpful to add arrows when we're multiplying out two brackets so that we can see this clearly. So n multiplied by n gives us n squared. N multiplied by 2 gives us 2n. 1 multiplied by n just gives us n. And then 1 multiplied by 2 gives us 2. And we can again simplify this down. And finally we'll want to multiply all these three numbers by a half. Now we can add together the like terms. So we have n squared, n, and then the numbers. So if we start off with the n squared terms, a half n squared add a half n squared will just give us n squared. Next, a half n plus 3 over 2n will give us 2n. And finally, there's only one number, so we can write plus 1. So now the final thing we'll need to do is we'll need to factorise this here so that we can prove that it will always be a square number. So in order to factorise this, we'll need to find two numbers which will add together to make 2 and multiply together to make 1. So 1 and 1 will add to make 2 and multiply to make 1. So we can rewrite n squared plus 2n plus 1 as n plus 1 multiplied by n plus 1, which we can again rewrite as n plus 1 squared. Now as we can see, n plus 1 squared will always be a square number because it's got this squared here. And we can substitute any value into n and it will still give us a square number. So the final thing we need to do is write a summary statement. So we can write something like, therefore, the sum of these numbers will always be a square number because a half n brackets n plus 1 plus a half brackets n plus 1 brackets n plus 2 is equal to n plus 1 squared. Now this question is worth 2 marks and we'll get our first mark for expanding out these brackets here for both of the numbers, and the second mark will come from completing the proof with an explanation and reference to this n plus 1 squared.